Hello again, everyone, and thank you for joining us today for our latest HashiCorp snapshot titled Job Templating with Levant for HashiCorp Nomad, which will be presented by my colleague, Anthony Burke, Senior Solutions Engineer at HashiCorp. So today, Burke is going to show us how Levant enhances HashiCorp Nomad with usable, automated, and operator-friendly deployments. Before we get started, I just want to go over a few housekeeping items. First of all, this whole webinar will be recorded and the link will be made available to you in the next day or two. So you'll receive an email from us with the link. And secondly, please submit any questions you have throughout the demo via the Q&A tab that you see at the bottom of your screen. And our senior solutions engineer who is with us today, David Wright, he will answer them as we go along. So with that, let's go ahead and get started. Over to you, Burke.
Thanks, Easy. Appreciate that. So before we start, I'm just going to touch base on a couple of things. So when we plan this session, we're going to do Levant on job templating and how to automate this job life cycling and these wonderful things. Since then, we've announced Nomad Pack, and Nomad Pack is the evolution of job templating that will become native to Nomad in the near future, and it was announced just this Monday past, so 2 days ago. So with that, we're going to have the same themed snapshot. So what you've come for will be the same content. We're just going to talk about Nomad Pack, which is hot off the press and it's in tech preview as of yesterday. So when Eric was introducing Levant, it's now Nomad Pack, but we'll go through that there. So get excited. So this is super fresh content. You might be the first in the world seeing this stuff, but it's ready to go. So we're going to talk about today. If there's any questions you have at all, please let me know, and we'll go from there. All right, let's get started. So I'm Burke. I work at HashiCorp. I've been here for a little while now, and I focus on schedulers, runtimes, and application delivery at HashiCorp. So let's talk about scheduling applications. So for HashiCorp, we have a number of products that we're known for: Vault, Terraform, Consul. We also have a scheduler, and our scheduler Nomad seeks to provide scheduling functionality for container runtimes, for application runtimes like Java, .NET, and do so in a consistent manner across all infrastructure. So if it's a Mac, Linux, Windows runtimes, we play consistently across them, which gives Nomad the ability to schedule applications anywhere you need to. It lets you to run an application like an IIS application and take that IIS application you have now on Windows, push it through Nomad and leverage the IIS driver and take advantage of scheduling such as A/B testing, application deployments, canary testing. And that ethos of HashiCorp's consistency in workflow is what drives Nomad to where it is today. So the use case for us is simplify container and runtime orchestration. And the idea here is that we can integrate with our existing applications such as Vault and Consul to take secrets and service discovery as part of the platform, and then provide that wherever the runtime needs to be. So if that needs to be on premises, if it needs to be on Azure, AWS, or GCP, we can run that there. And that can be on a varying number of operating systems. The challenge of going from any sort of test environment to production with any scheduler, that's K8, Mesos, Nomad, whatever it may be, is that you can run it locally and go, cool, this app runs in a container, or this app runs on a scheduler. But when we move into production, it comes quite complex. You need to think about security, networking. Is it portable? Can I federate? What about configuration changes? How do I run this thing? How do I orchestrate it? How do I monitor it? And the idea is that we take our existing job files and we start to build out, if it's YAML or HCL, we build out our configuration for this job and we start adding these things in. What enterprises seek for is application consistency. The idea that we can provide, a templated way of doing networking, a consistent way of doing security, a consistent way of doing configuration regarding these job files to ensure that I can have that around my, whatever application I stand up. So we move to about templating applications, and this leads into how do I get reusability out of these applications? And so I'm not forgetting about the important things like security or role-based access control or network connectivity. Looking at a Nomad job file, you can see here the Nomad job file is based on HCL, like all of our products are, which is a friendlier version of JSON, which is human-friendly and machine-readable. It supports for Nomad the notion of job, group, and task units, which allows us to define one job with many groups and one or many tasks. Supports for variables and is the starting point for us as operators to get up and running with Nomad. You might have YAML files for K8s, you have HL job specs for Nomad, right? You can see here that this job here is a Docker container that gets up and running. Super stuff. But if you want to reuse that, well, this is pretty static. I need to go through and modify it, change the data center, or change the group name, or change the driver. And it becomes very cumbersome to duplicate that. So to reuse these job specs, we want to start looking at templatizing various things. So here we want to start going, okay, what do I do here? I need to look at adding variables in. I need to start leveraging potentially templating, the idea of taking my configuration specific code in my job file and adding it to a template file. The idea here is that I can overlay variables or a configuration file that will personify my job, which makes it reusable and far more friendly. But where it gets too challenging is how do I start lifecycling and managing this, for my applications internally, applications externally, and more so provide that at a scalable level. Well, this is where Nomad Pack comes in. You may have heard of things like Helm for Kubernetes. Nomad Pack or Pack is what Nomad uses. So do you want a quick open source application or need an application configured? If you do, a pack is what you're after. A pack provides a repeatable way to deploy an application. It includes its networking components, its storage components, its configuration settings, and then provides a way to customize them to modify it to your environment. So essentially, we can do Nomad Pack run, pack name, and it's going to deploy if it's Apache or Loki or if it's Nginx traffic, sample application 1, whatever you want to describe in the pack. And it takes that evolution of writing manual job specs and to have modularized portable packs. So there's 3 main components in a pack. Look at the anatomy of a Nomad pack. There is the template, which describes essentially what needs to be configured and when it is rendered via the Go templating language, which is either Consul template or Nomad template. If you dig into it, it will spin out a job spec for you, which is super. And that takes its inputs from the variable files. The variable files are what essentially modifies the different pieces of the template. So for example, there's a number of variables configured by default, and we'll go through this in a demo shortly. And you'll see here that this will provide the inputs for that template. And then the metadata wraps it up so when it's discoverable on the registry, a centralized place to discover different packs, you can see what version it is, what variables it has, and various information. Again, we'll cover this in a demo shortly. The metadata file here includes that pack information, as I said, and any links to any particular documentation or the app itself, like nginx.com or HashiCorp Nomad integration or autoscale integration. That template file you can see here, I always get excited by this stuff, so I end up speaking over my slides, is that you can see here the job gets rendered. And when this gets rendered, the template will be the job's full name, the region will be passed from the region value, the data center value will be looked up from data centers. And the idea here that instead of having to manually code this, I can write my template, overlay this variables file, and everything gets added to it, which is a nice way of providing the ability to go, I want this app here, here, and here, and provide the relevant environment variable configurations. That abstraction is what drives the flexibility here too. That variable file that we overlay here, you can see here just standard HCL variable file, a description, a type, and the default. If I don't specify anything over the top in my overrides file or anything like that, default will be global. Well, the default namespace is default, right? I could append a variable saying the namespace is Burke, and it's going to be put onto the namespace Burke. So it gives you, so from a point of use, I can go, cool, there's a new application out on for Nomad. There's a Nomad Pack for that. I can do Nomad Pack run new application, and it's going to run with all its defaults. So quick to get up and running, which is super. If you want to find out what variables we can change, you just do Nomad Pack info and then the name of the pack from your registry. And you can see here I can override like the namespace or the agent task resources or the job name or region to help provide that sort of control. And instead of having to write a very long job spec with what ports I'm listening on and defaults, it's all done for me, right? If you're familiar with Terraform modules, think of the same thing here. There's a lot of defaults chosen for me, and I just provide the mandatory attributes, which is very nice. If I want to override a variable in a pinch, I can quickly go, dash dash var namespace equals test or dash dash var dash file and provide an overrides file, which lets me very quickly override those defaults. So same base pack with customized variables on top. Super way to get up and running really quickly, and the ease on reuse here. I could have multiple variable files for different environments. So that core pack's the same, and the customizations in that abstraction of variables. So given that this is a short, sharp, punchy little snapshot, I'm going to go into a demo here and go through an environment. So let me just open this up here. I have on my screen here a Nomad environment. Now, I will preface today that today's demo is part of a tech preview beta that was released just on the weekend. So if you want to use this is in tech preview. It will enter GA very soon, but as you can see, 1.20 beta is required for this. We'll go off and install Nomad Pack. We'll just build that from source, and you can see here if I do Nomad, I'll make this a bit larger. I always forget to do this. Nomad Pack. You can see I have my Nomad Pack here. So what we're going to do today is just get a feel for Nomad Pack running. You can see I have a valid environment. This is live. I'm not hiding anything from anyone here. So what we get started, we're going to do Nomad Pack registry. So the registry is that centralized place of where I can store various different packs. By default, there is a Nomad community registry where we as HashiCorp host a number of applications. This is ever growing. You can make contributions to this, but it's a list of all registries. As an operator of a Nomad environment, you can host your own registry because essentially we just look at a GitHub repository and pull that down. So what you can see here, by default, we have Grafana, HA Proxy, Nginx, Nomad Autoscaler, and Simple Service to get a feel for different things that are running in my environment, or could be running in my environment, right? So, and we can search this registry, or search is coming, but we can be able to search these sort of things and do that sort of stuff. So let's look at what about this Hello World application. I'm interested in using this. So Nomad Pack, I'll go info Hello World. And you can see here, the Hello World is a simple application with an optional Consul service. I can see there's information about it from the learning tutorial, which is super. I can see there's some variables here. If I run it, I can override various things, which is not bad. So if I was to look at this and go, okay, I'm interested in seeing what this is about, I'm going to see what the configuration looks like. And so what you can do before you run this, you can, given this is all templatized, right? If I go and look at the Hello World application and click this and go into my packs, I can see the Hello World is made up of the output variables configuration, as we've discussed before, where you can override those variables. Just going to move the little zoom thing here to that side. I am going to show off here the templates, and the actual template code itself shows off the templates and where we'll populate various things, right? So nothing hidden away here. But what I want to see is, I might want to see, before I run this, I want to make sure that the valid output. So I'm going to do Nomad, change back to that. Nomad Pack render Hello World. And what it does for me, it shows based on the environment in currently running what the job would look like. If I was to actually write that by hand, this is what the job would look like. Due to Nomad Pack, it renders that template for me, adds all those variables in, and away we go. So you can see here, you can do Nomad Pack, and you can see it's rendered. I do Nomad Pack render Hello World var message equals Burke. I can see that there it's rendered. That's what the job's going to look like. Message with Burke. Super. So I'm going to run this. I'm going to do Nomad Pack run Hello World. The count will be equals 2, and the variable message is going to equal this is our snapshot. You can see there, that's deployed something to Nomad, right? It's gone off and deployed it. I've successfully deployed something. And if I wanted just to validate that, Nomad Pack status, I can see that that's running. I go hello world and see that's running, right? That's great. And if I validate this in a Nomad CLI, Nomad job status, I can see hello world is running. And I can then check out hello world in a bit more detail and see that there is an application running. If I go to my UI and just hit refresh, I can see that it is running nicely. I can see that the application has been managed and deployed via a pack from the default registry, running the latest version. Nothing too exciting in the sense there, but I can also see that there's pack information about who ran it. Burke ran the pack, that's fine. Happy days there. And if I click on this application here, I can see that the environment variable, this is our snapshot, was passed through, right? Which is a really cool way of seeing. You can see us customizing things. And from there, you can see that it's happily running, it's been managed, and I can then start to run multiple packs of the same thing with different environment variables, or multiple packs with different job names. So for example, I could run the same job with the name snap, the name snap, and it would allow me to do that. So I shouldn't plan, I should run that. I can also do Nomad Pack, and I can do Nomad Destroy, and I can destroy my hello world if I want to, and it's going to destroy it. So you get that control of lifecycle there. So if I was to do my snap then here, I can deploy one called snap, and then I can do, if I want to change any variables, I can reference snap again, do variable count equals 2, variable message, for example, equals Berkey, right? I can see that's applied that change and that's done a delta change to my environment because I'm configuring the same snap again, like the same snapshot again, right? Which allows me to quickly see that there is a job that runs that has a different name and different count, which is great. And then if I do that run, then becomes run, you'll see it gets deployed in my environment nice and quickly, which is really good. So all right, we do that there, and then I can just, if I want to change the same snap, I can modify that and do Nomad Pack run hello world name equals snap, and var count equals 1. Right, and I can see I've modified that particular one here, and you can see in the Nomad history that the changes occurred and there's a differential in this environment. So you can get a feel for how that would work, how the change works. If I do Nomad Pack status and then hello world, I see more information about that particular job there. And then I can always clean this up with destroy, and a name would need name equals snap. And that destroys that particular job there. So if I get back to my little screen here, click present. That was the topology we used. I always get excited about these sort of things. It's a simple Nomad environment running, Nomad Pack running for us to manage the environment and the application lifecycle. So what are the takeaways, right? It provides us a way to template lifecycle applications. I can operational control of a number of applications with simplified code. We can take advantage of dry principles, don't repeat yourself. So essentially allows us to apply these overlay files that allow us to take the variables and customize them for our environment. It simplifies our job spec and management times. I don't need to write complicated job specifications. I can write a template that's expanded about by those variable or override files. Having a centralized repository for applications, either self-hosted or leveraging HashiCorp's one, allows us to centralize and collaborate and share. You might have a new app or come to market with something, and you can share that with your friends, family, customers, whomever. And in the short term, this will be integrated into the Nomad CLI. So it won't be necessarily Nomad Pack as part of a separate build. It'll be a Nomad Pack as part of the Nomad binary itself. There'll be AC access controller support to define ACLs, search commands, and a bit more coming. So I hope you've enjoyed this tech preview and discussion regarding how this can help your environment today. This has been I'm Berkey. This was Nomad Pack, and thank you for coming to the snapshot.
Thanks, Becky, again for giving us this sneak peek of Nomad Pack ahead of the GA, right? So now I can't see any questions in the Q&A tab. So folks, if you have any questions, please drop them in the Q&A tab right now. It's at the bottom of the screen. Or you can contact Berkey as well via the email that you see on your screen right now. All right, so I guess there's no further questions. So well, folks, that brings us to the end of today's, one question popped up here. Why would Nomad be preferred over Kubernetes? Burke or David, any
Yeah,
one of you?
sure.
Yeah.
So Galib, so we have a lot of customers who find there's a lot of complexity with Kubernetes and running K8s environments, and the whole idea of, for some customers, the idea of lift and shifting applications that might exist on premises already. So, for example, it might be a .NET application or a Java application. Given that we can natively schedule Java applications and take the same binary, they wouldn't necessarily have to re-platform into a container, then run on K8s, is an example of what Roblox do with IIS and other customers. In addition to that, we find that we have ability to provide federation and other functionality for Nomad in a straightforward method, whereas if you do add it to K8's other things, federation becomes a complex task. So we focus on simplicity and straightforwardness. There are workloads that are better designed for K8s, and we accept that. And we have a lot of customers too who run Kubernetes and Nomad side by side. For Windows VMs, we wouldn't containerize the VM per se. We can schedule virtual machines as QEMU, but you would most likely look at running SharePoint, like because SharePoint uses IIS, you would be scheduling up SharePoint into IIS, for example, with maybe a SQL database on the side. Probably more nuance of implementation detail, but it could be done.
Okay, thank you, Galib, for that question. We have another question from Suraj. In Nomad Pack, we will have to template everything then, like CPU and memory port, etc., to have controls over them based upon environments.
Yeah, so you would have to write this anyway, like by default. Like if you write a job spec, if you don't specify reserved memory, it just will use what it needs to use. Right. So if you want to control that via a template, yes, you would have to write it into the template. So it's really, you write it in the job spec or the template. By adding it to the template, you can then customize it via override files or variable files, which gives you that control. Helm charts offer the same thing, right? Like it's not a new concept. If you want to control it via Helm, it needs to be in the chart. So it's probably the same mentality there.
Okay, thank you both for your questions.
That's cool.
Great. Okay. So if there's no further questions, that brings us to the end of today's session. We hope you found it useful. As I mentioned earlier, this session is being recorded. So we'll send you the link to the recording once we are done with the session. And if you like what you hear today, you want to know more about Nomad Pack, right? Visit us at our Learn pages. That's at learn.hashicorp.com. Thanks again for joining us today. And a big thank you to Burke and David for sticking around to help us with the Q&A. Enjoy the rest of the day and bye for now.